the number that repeats 3 times, which is 2 on your list. Circle all your primes. You bring it outside once. That's how you simplify it. So you bring it outside once. Now, how's that? Because the 3 tells you that. The root number tells you how to bring it out. Yeah, so you have to bring out every 3 one time. So it's like a 2 out here. But you don't have anything left, therefore you keep it inside. So here's your final answer. Now, if you were to do a little faster, I forgot that is the third. You could. If you recognize a cubic number as a factor of this 24, which is 8 and 4. Say 4, let me see, is that right? No. What is 8 times 3? Sorry, 3 times 8, right? Yeah. So this 8, if you remember, is a 2, 2, 2. So if you were to show the work, it would have been like this. 8 cube root of 8 times 3. And then you might have seen that, hey, it's split up into, now you don't have to do any of this because it's a lot of writing. It's split up into 2 cube roots. It's always a product. If you can split them as a product on their own, like a product of 2 separate roots, cube roots. And then this one, you're supposed to know that, hey, it's 2 because it's 2, 2, 2, 2 times 2 times 2. So that's why that comes outside, and this is what left back here. But if you were to do a tree method, you could just like organize it the way I did it. Pull out once, and whatever you have left, just leave it in there. Sometimes you may even have a 2 left, right? But you already collected 3. Let's just say, right? That means you'll have a 6 left inside the root, the cube root. Is that okay? Yeah. So because you can't continue, so that's could be the case. So anyway, that's the answer. But let's see the next one here. This one. Leave the 8 out here. Here, 4th root. Yeah, I would recommend you break them all up, try and factorize it. Because you don't do the list of 2 to the 4th power, 3 to the 4th power. No one does even 3 to the 4th power. I don't remember, especially 5 to the 4th power. No. Yeah, that means you have to do the tree. It's not very recognizable. 16 maybe, 64 maybe. Some of you guys may know it, but no, this is too small. 48. All right, break them up. Half it because you can. 20. Circle the prime, which is the only prime is 2. Half it again, 2 and 12. Half it again, 2 and 3. No, 2 and 6. And then half it again, 2 and 3. Here we go. You look for, because of the root number, you look for the number that repeats 4 times, you bring it outside once. Here it is. But when you bring it outside, it will be times it to whatever number already exists in the front, which is going to be times the 8. Oh, sorry, let me rewrite that. All right, that's bad. If I erase it, it'll probably give you weird like white here. So here we go. It's a negative 8 times 2 one time. And whatever you have left is still going to be that same root, 4th root of 3. That's it. And not yet. Multiply this one last time. It will be 16, 4th root of 3. There's your answer. Now, there's something here that I send. Okay, so let me ask. So you said that you don't have to do anything relating to absolute value, right? Mm-hmm. Because it happens right here, by the way. You sure, right? You don't remember your teacher ever showing you that?
Let me grab my notes. Hold on.
Yes, please.
I don't see anything about absolute value in here, but she had us stop at like question 11 for the notes, and then we're going to do more tomorrow. And I think once we get to tomorrow's stuff, it looks a little bit harder, so maybe she'll use it then. But
okay.
For what we did today, there doesn't seem to be anything about that.
Okay. All right, that may be okay. All right. That sounds good. All right. Yeah. it applies for the variables. Like I'm looking at it right here for number 5 and number 6 happening. The absolute value should be written technically for the answer. I'll write it with and without, and you can kind of like have. I think your teacher will go over it anyway. Okay, continue with this one. 96. Now, odd root, right? Odd root. You can bring out the negative, but before you do it, just to confirm it, you're gonna do that prime factorization. Find 5 numbers that you can pull out. Then I'll show you why you can pull out the negative. It's just a rule. You can think of it. If you have an odd root of a negative, it's fine. Only when you do imaginary thing, like, or no real solution, is when you do an even root, like square root, fourth root, whatever, of a negative. But odd root of a negative, it's fine, and I'll show it to you here. You could just pull it if you want to memorize it for quick math. You could just pull it out. But let's break this thing up. So have a 96. What is that? 45. Have a 3. 48. Yeah. Half it again. Yeah, because some people recognize like something to the 5th power. I don't. I'm sorry, dude. I'm not that smart. But yeah, even 4th power, because yeah, no one really does that. Yeah, I don't know. Let's see what happens here. 24. Keep going. 2, 12, 2, 6, 2, 3. So you're telling me that you know it's what is this? Let me see. 96. Okay, you know that is you know that it's 32 times 3. Do you know that 96 is 32 times 3? Yeah, some people can, but you still need to know that 32 is actually a perfect 5th root number. I don't think anyone knows that. That's why this may be
I
the
may
only
know.
option. Yeah, I know, huh? What am I talking about, right? Like, it's like 32, right? This one I actually know. 32 is equivalent to 2 to the 5th power. Yeah, some people have this down. This 32 is actually quite common, but the thing is that I don't know that it's in 96. I don't know it's a factor of 96, dude, without actually doing this. Actually, kind of, I can, but it wouldn't be practical for the student to learn it anyway, because they wouldn't want to memorize that. That's why. But yeah, for mathematician and people actually, for teachers, maybe. But anyway, okay, so this is how this works. It's a -2 times. You don't have to do any of this, but you want to prime factorize it, of course. You want to do the tree thing, but I'm going to prove the negative here. So there are 5 negatives. If you multiply them, right, -5 times, it's still going to be negative. If you remember, right, you multiply negative number, 5 negative numbers, or odd times, multiplying negative number odd times, right? You will get negative back. Therefore, -2 times -2 times -2, like 5 times, will give you a negative number, that a -32. That means it will come out exactly that. As long as you can prove it, that it's actually a negative number back inside the root. But forget all of what I just said. You just pull it out, because how do you mean pull it out? You pull out a -2, and then this negative should be out when it's an odd root. Then keep whatever you have left inside. Oh, I forgot the x now. This here, there's nothing you can do, because you only have x 3 times. Had it been x to the 5th or above, you'll be able to pull it out. I don't know why they give you that. They should actually, since the 5th, they should actually make you do it right away. But nothing you can do for the variable, so you keep it in there. So anyway, the only thing you can pull out is a -2, and then you're left with that 3, this 3 right here, and then the x to the 3rd. There's your final answer. But I'm sorry, keep the 5th root. It's still a 5th root. Yeah. Now, we better have the chance to actually simplify something like this, by the way. For example, had it been a 6x to the 6th, 5th root, let me show you how this works. If this were the problem, let's just say ignore all that, and this is just the problem, you can have a number in there. You would rewrite it like x to the 5th times x inside there, 5th root, and then here it is. It repeats 5 times, right? So you pull out once outside. because x 5 times, x times x 5 times. And then whatever you have left in there, that's what you keep. That's how this is what this turned into. But it's not this problem. I don't understand it. Why would you even introduce something smaller than the root number or the index number? Whatever. Okay, now 45. Now this one, I recommend you actually look because it's in your timetable. So you want to brainstorm it. It is a 9 times 5, right? So therefore, I'll write the expansion to show what my thought process is. So it's 9 times 5 and p squared. So here it is. This is where the absolute value is going to come in for the variable. But I'll write it without first. So anyway, then you can imagine you break this into root 9, root 5, p, whatever, root 5, p squared even. You can do all that. You can keep them together in here if you want. That's why this is going to be a 3. But no one does this, really. Some people still do that. It's too much writing. So it'll be a 3 outside because it's a square root of 9. But the rest should stay. Oh, and the p comes outside. Here it is. The p comes outside because it's p times p, so it comes outside once. Imagine pp come outside, even number of p's. So you come outside. And then whatever you have left, you keep. But here it is. There's a rule here, by the way. So let me kind of show you that if I can. Okay, let me show you the rule here so that you understand that I'm not actually making this up. Absolute value. It's actually important. Absolute value, absolute root, absolute. I don't know how such a absolute in root. I don't know in root, in value in root. Okay, something like this. All right. Watch, they're probably AI it. Okay, fine, whatever. But have a look here. You see, this is the definition right here. When you actually absolute value of anything even, it comes outside as an absolute value variable. Only for a variable. Okay, not numbers. It comes outside like that. So here, you can even look at this here. More example. Check. Look. So now there's more going on. It's not always going to come out like that, but I'll explain the fourth root. I'm sorry, the fourth power in a square root. I'll explain that. But look at the square. But look at this one here. Look at 36x squared. See, it comes out as a root there. But okay. Now, what about this one without the x to the fourth, right? What about it? If you actually can simplify it coming outside as an even exponent, you don't need to put absolute value. If it come outside as an odd, then you have to. It's like, that's why there's a concept on its own. They don't show you that here, by the way. I don't mean the third root, okay? I mean the even root, not the third root here. They didn't show you that, but I can show it. I mean, I can dig into it more. But anyway, go back to the work here. What is that there? I don't know what I do there. But anyway, let's go back here. So that's why this should have been written like this. That's why I left a little gap there. So this is actually the right answer for the p squared. Now, if you haven't been taught, you could just leave it alone like that. But I'm just gonna write this on the side here, so that yeah. So, but then I'll look for more that you were required to do it. So this is technically the right answer. Now, 5. This one, 44. I see 4 times 11. That 4 is a perfect square. And look at, here we go, the m to the third. You can break this m to the third into m squared times m. The m by itself, I'm sorry, the n squared, leave it alone. Now, why am I doing that? Because this can be divided by 2, because there's 2 of them, like a pair. So you can bring it outside once. Now, it'll get more fancier. What if it's like to the 7th power? Then I'm making this up here. If you have m to the square root, okay, there's a 2 here, to the 7th power, you would think you would break it up as m to the 6 times m. You would do that because that 6, you could imagine there are like 6 of them, but you pull out 2 of them at a time. But you don't have to write them out. Just go ahead and divide it by 2. It'll come outside 3 times, 3 pairs. So that's a concept, by the way. Sometimes they write 6 divided by 2 as a fraction. I don't think so, but that's what your teacher would explain it if he or she would need to. So the answer for this one, though, it would be a m to the third and m, like that, for this m to the 7th. but that's not what we're doing. Okay, anyway, back to this one. So if you do this, right, it'll be, this one comes out as a 2, this comes out as 1m, this come out as 1n. But the right answer is the absolute value, dude. So here we go again. So I'll write it without first. It'll be 11 left over and an m inside. And then the right answer would have been 2mn together, absolute value, a root of 11m. So, but I think you may be able to get away with just that without the absolute value symbol. Okay, same thing with this one. Oh, it's 72. In your timetable, a 9 is the biggest perfect square. So here is the work that we show. Okay, I hope you're okay with that one. It will be 9 times 6x squared. So if I show the work, and the 9 will comes outside as a 3, so it'll be 6 times 3, and this x squared will be an absolute value of x right here, like that, and a root 6. But I'll write it without the leftover. So a 9 comes out right here, this x comes out right here. Then you have to times it by the number that already exists in the front. It'll be 18x root 6. The 6, yeah, it stays in there. But again, it might be 18 absolute value of x root 6. Yeah. Yeah, it's a concept there. I have a feeling the way I'm looking at it right now, the further I work down, your teacher may not actually care for the absolute value because they're not that big. Had it been bigger, then that's more like it because it's more challenging. I don't know. I don't know that for sure. But let's continue here. So I leave -8 outside. 24. The only perfect square number, it's a 4 that I can see. Let's see. Here. 4 times 6. So I'll write it like that. Because 6 doesn't have anything in there. So 6 is 2 times 3. So you don't want to break that up because there's no repeated number, only 4. But k to the third can be written as k squared times k. Now this here is actually the method. They actually show it exactly the way I've written here, like the step. It should look just like it, like right here. That k to the third should be broken up into an even number, the biggest even number that is divisible by 2, which is this index number here. You don't see it's a 2 there. So, but this is the biggest is 2. And then divided by 2, it comes out as an k outside. But anyway, here we go. This comes out, this comes out. It'll be but 8 already exists, so it comes out as a 2, comes out as a k, technically absolute value, once again, okay? But I'll leave it without. And that's it. And then leave everything that's left in there, 6k. And then multiply this part in the front. 16k. Should have been absolute value right there, but I'll write it over here. -16 absolute value of k root 6k. But you're saying that your note doesn't have any of that. But you guys went over this before you were assigned, right? Like sure. Okay, so no, I think no absolute value, but I think eventually you will.
Yeah.
Okay, no absolute value. Because it's not just this, dude. There's actually more to it than just the 2. Yeah, no kidding. There's more to it. But I guess we'll finish this and I'll bring it in. I'll show you all of the possible variation of it. But I guess,
Okay.
yeah, later. Yeah. All right. -3. Again, 24. Brainstorm it. It's a small enough small number that it's in your timetable, so you should brainstorm this. Every chance you get, you should do it if you recognize the number to be small enough. So it's only a 4 and a 6. I keep writing the perfect square first. You don't have to. You can do 6 and 4. So I can bring it out outside. So so 4 and 6 again. Here we go. The a to the fourth, you will leave it alone because it's already the exponent is already divisible by 2. So leave it alone. B squared is the 2. The exponent 2 is divisible by 2, so leave it alone. The c to the third. Now we're talking square root, so it's 2 here. So you look for a number that can be divided by 2, not the 3. Therefore, you have to break it into the bigger one right away, divisible by 2, and the smaller it's 1. So there's your short work. This is how they would They would do it, okay, in textbooks. They would show exactly this as the next step. And here we go. And then you bring it out. The -3 stays -3. The 4 comes out as a 2. This here, it's really a to the 4th divided by 2. Or you can imagine, so anyway, if I were to write that right away, it would be a squared. Why? Because if you actually gather, you imagine you expand 4a's inside the root, you have to pull out every pair once. But there are 2 pairs of, because there are 4 of them, right? So every pair you pull out one time, so it's a, and you pull another one outside, another a, you multiply, it become a squared on the outside. But the fastest way is that if you have a number that is even, bigger than 2, like a 4, you divide that 4 by 2. That would be the answer immediately on the outside. Is that okay? Like divided by the index number right here. Same thing for odd. No kidding. Same thing for odd numbers. 5, 5th, 7th, even. But anyway, and the next one should be just B. Here it is. Let me cross out what I already pulled out. You don't have to do it, but I always do it just so I don't recopy it. So B one time, and then C one time, and then whatever you have left, keep it. So it's 6C. So there it is. But once again, you may have to write the absolute value. Guess what? Here's the rule. You won't absolute value the a squared, but you absolute value the b and the c. So there's so much going on. So I believe now that your teacher may not have, introduced it because there's more to it. So it's like you can't be writing it here. That would be wrong. There's reason behind it, but then forget it. Don't do absolute value right now. Oh yeah. So I'm sorry. You have to write this as a 6, a -6, and that's it. And everything else as is. Because you can multiply it on the outside. Okay, 48. You okay with that? This one, the 2 stay -2 outside, but 48. Brainstorm it a little bit. Okay, it is 16 times 3, but you wouldn't know that, right? 16 times 3. 16 is the biggest perfect square number. Let me check that. Yeah, so I don't think you guys will know that. I'll do a tree. So here, 16 times 3 would be 48. Now many of you guys won't think that. Not that you don't know it, but you wouldn't think it. But if you divide it by 3, you'll know it right away. But pretend you didn't know it. Let's do it here, 48. Right? You probably didn't see the 16 in there, right? The 16 will be the big perfect square. So let's pretend you didn't do that. So I think you're probably going to do a 4. Okay, fine. But circle a 4, but it'll come out as a 2. 4 and 1 and 2. And here it is. If you continue with this one, you might want to do a 4 again. See, you want to do a 4 again. You don't want to do 2 and 6, because if you can see that you can bring a repeated number, biggest, then you may want to do that. Again, you don't have to do this. You can go ahead and have every single thing, but gather every pair outside. Is that okay? Then multiply them. But this is smarter. It's still a little faster, but the fastest will be 16 and 3. But we'll skip that.
Yeah.
So this will be done right here. Still circle that. This 2 is a pair that I would pull out as a 4 on the outside. Or here it is. Let me double check. Yeah. So it'll be a 4 one time outside, but the 3 will stay inside. Oh, but how would you show it inside the root? Since you did a prime, if you did a tree, you don't show anything. Just pull out the answer and then start gathering what you have left. Is that okay? I don't think you need to do that. You don't even have to show the expansion inside, like to equate to 48. Don't do it, because you did a tree. The word is already outside. It's too much to write. I don't recommend it. You show enough the work like this already here. So you don't have to do it again. Your teacher will be fine for sure. So if you did a tree, you don't have to show what it's going to be turned into 48 inside, like a long string of things in here to give you 48. So forget it. So bring it outside. But keep in mind the 3 better be left in there. Okay, so keep that in mind. The 3 stays. Okay, now what about the A? Oh, shoot. I forgot. Since there's more, dang it. Since there's more, you may have to show it. People do different. They skip things but then they write the final answer correctly. It's fine. But since there's more, I think you may have to show it. So let's show it. I'm sorry, dude. Let's do it, okay? So let's do it. Because it's safer to get the answer correctly for the rest of them. That's why. So, okay, you did the tree and you recognize there's 4 and 4 here. You could do that. You could go ahead and write 4 squared times 3. Like that, you see? It's 16, 3. like I was saying earlier. But you don't have to write 16. You can write 4 squared because you're about to pull it outside once. But you could write it like that. 4, and then because why? Because of this right here. Because why am I writing that? Because of this. The rest of it, you have to write a squared times a. You don't have to if you know how to actually mentally do it. But I think you should do it like this so that it's safer. Later on, you can mentally do it. B to the fourth, stay B to the fourth because it's divisible by 2, like this one. And then C squared is the square, the 2 is divisible by 2, so leave it. Here it is. So, and then you gather what you have left. Gather outside and inside. This comes outside once, so as a 4 because it's squared. This comes outside once as an A. This comes outside twice, but you can write it B squared. Divide 4 by 2, or you imagine, two B's because there's 4 of them every pair. And then the C one time. There it is. And then you have only 3A left. This is nice if you do exactly. Everything I've done is very methodical. If you do it, you're not going to under. So here's the final answer. 8AB squared, because you can multiply that, right here. And stay negative. And 3A, final. But again, the correct answer would have been the absolute value of A and C together, and the B squared could be wherever in the front or behind. So here's the actual answer, but I don't think you're doing it. So forget that. Yeah, okay.